Morning, students. Already we have seen a video regarding the overview of mechanical engineering for the subject Basic Civil Mechanical Engineering, and this is my second video for the subject Basic Civil Mechanical Engineering. So, in this video, we are going to see about hydroelectric power plant, shortly called as HYDEL plant. HYDEL means hydroelectric power plant. So, you all know that hydro means water. So by using water as a source, we are going to generate power using a power plant. That power plant is called hydroelectric power plant, also called as HYDEL power plant. So seen here, a HYDEL power plant is also known as hydroelectric power plant that uses the energy of flowing water to generate electricity. So you all know about the dams. In Tamil Nadu, we have Mettur Dam, Vaigai Dam, Periyar Powerhouse, like that throughout India, in world also. In China, we have the world's largest dam in China. In India, also in Maharashtra, we have the largest dam in India. So in that, hydroelectric power is generated. So usually, dam is used to store the excess water what we collect from the rainy season. So we all know that monsoon, southwest monsoon, northeast monsoon, during that time every day we will have rainfall, so enormous water will be collected in the catchment area, and that water will be stored in a dam. For example, in Mettur Dam, during our northeast monsoon, up to 120 feet of water, like that each dam will have its own capacity. So that water, when it is stored to a fullest capacity, that possesses the potential energy because of the enormous water stored. So that potential energy is converted into mechanical energy. That mechanical energy is converted into electrical energy by using turbines. So the enormous water will be released using a gate valve that will be sent through a pipe called penstock, and the jet of water under high pressure will be sent to a turbine. There are so many type of turbines like a Pelton turbine, Kaplan turbine, Francis turbine, like that. So the water jet will go and impact the blades of the turbine, so that because of that the turbine will be spinning, will be rotating. So the hydraulic energy is converted into mechanical energy by rotating the turbine. So that turbine is coupled to a generator. In the generator, there will be a magnetic field. The shaft is rotating. It will cut the positive and negative, and electricity will be generated. That is why it is called a generator. So the generator produces electricity by means of the rotary motion of the turbine. So that electricity is sent to the transformer for stepping up, and that will be sent to the grid for transmission of power to all domestic purpose. This is the working principle of hydroelectric power plant. If you see the layout, this is the hydroelectric power plant layout. What we see here is a dam, uh, that it is called a reservoir. So more amount of water what we get during the rainfall season, monsoon season, will be collected and stored in the dam. So when the enormous water is stored, it reaches the fullest capacity. At the bottom of the dam, you will have a pipeline, and it can be controlled by means of a gate valve. So for power production, when the dam is of full capacity, if you want to produce power, you have to open the gate valve. So through the gate valve, high pressure water, the potential energy of the water and the high pressure will be sent through the pipes. That pipe is called the penstock. It may be either made up of concrete or steel. which are all connected by supporting blocks also for safety purpose. And there is a surge tank. The purpose of surge tank is that suppose if there is a block in the water flow, the water will get backfired. It will reverse, so it will come back as at a high speed and high pressure also. So if there is no opening, it will lead to even exhausting, like bomb. It will explode penstock pipe. So it is not safety wise. It is not advisable. So for safety purpose, there will be a surge tank. It will have an opening. If suppose there is a backflow of water, it is called the water hammer effect. Because of the backflow, high pressure water will come out and it may explode the pipes. To safeguard the pipes during the backflow and avoid the water effect, we have a surge tank. Through that opening, the high pressure water will come out and it will be safety for the penstock pipe. It will not be. That is the reason for using a surge tank. It is for safety purpose only. So under high pressure, it will go through the inlet valve to a turbine. So we have a turbine here. It may be a horizontal turbine like a Pelton wheel. It may be a vertical axis turbine like a Francis or a turbine. So the jet of water at high pressure will impact the turbine blades. So that the blades will be connected to a shaft. The blades moving, the shaft is started rotating. So the turbine will get rotating because of the jet of water pressure. So that rotary motion of the shaft is coupled to a generator. So when the shaft is rotating, the generator will start producing power by cutting the magnetic field. That produced power or electricity is sent to the control room, where there will be some transformer for stepping up the voltage for the required voltage. It will up the transformer. That conditioned power is sent to the grid through the transmission line, through the cables. It will be sent to houses or hospitals. For all domestic applications, it will be sent to the users for electricity usage. When the water is after hitting the turbine, it will come out through the trapped tube. So why it is called trapped tube means it will be expanding nature. So high pressure water will coming out from the turbine. It will be expanded and pressure will be reduced, and that trap tube will be connected to the tail water level. The dam we have a headwater level at a high, very high height for having the potential energy. After it is sent to the penstock pipe and producing power, the water will be, it will not be wasted. It will be sent to the tailwater level. It will be sent to the irrigation purpose for farmers, for storing of drinking water, like that. Irrigation, mainly irrigation purpose, the water will be sent. So this is the working principle of hydroelectric power plant. And this is one more view of a hydroelectric power plant. Here you can see a reservoir like a dam. Under the dam there is a control valve, a gate valve. By opening the gate valve, we can control the flow of water. So it goes through a pipe called penstock, and it goes through a vertical axis turbine. This may be a Kaplan or a Francis turbine. It will rotate the vertical shaft. The vertical shaft is connected to a generator. So in the generator, electricity, and that power is transformed using a transformer. All the setup is available in the powerhouse. So from the powerhouse, the transformed power is transmitted through the power lines to the domestic applications. The remaining water goes out from the turbine to the trap tube as outflow, and it goes to the irrigation purpose or drinking water purpose. So this is the working principle of hydroelectric power plants.